Welcome to the Cape Computer Science Unit 1 IA walkthrough. This video is part of a series of 7 videos, I think, that will give you a full start to finish walkthrough of what the Computer Science Unit 1 IA is supposed to look like, giving you examples, working out the code, showing you the documentation, and giving you all the little tips and tricks in between about how you should approach your IA. So I hope you learned something, but just remember, I'm not a teacher. Whatever your teacher decides to tell you to do, follow what your teacher says. This is for people who don't have teachers, if your teacher's sick, or you're doing it on your own, right? So, enjoy! Alright, welcome to the video number 4, I believe. Yeah, this is video 4. Video 4 where we actually start to code the program down. And if you watch the previous video, which was a long one of course, because that's where the most marks are, it had a lot of stuff and we went through the design, we came up with the algorithm, we explained the files, we explained the inputs, outputs, we explained the data structures, we showed all the programming concepts, and we had a basic pseudocode layout that looked something like basically this. Alright, so we start off by saying, okay, this is the top here, which is the structure. We have the structure laid out. We put some global variables, we put a password function, we put a read file, all the different things, and then we laid it out and put comments by the things that we had to put in, right? Now what you'll realize in the mark scheme is that they specifically have a part of the mark scheme that says evidence that code matches algorithm, which is 4 marks. That means exactly how we laid out this algorithm, that's exactly how we have to lay out the code. And that's very, very, very important, right? Right. So exactly how we laid out the algorithm, that's exactly how we have to lay out the code. Because the code must match the algorithm. So I'll jump into this part here one time because it says code matches sequencing of algorithm, and then they have code matches most of the sequencing, some of the sequencing, meaning that your algorithm is supposed to be the setup that you use to prepare your code. You're supposed to use the algorithm as a guide for your code basically. But that's not always, it's not always easy to do because some students prefer to just do the code one time and doing all the algorithm stuff. It's almost like boring, and sometimes it's monotonous, and you feel like, alright, I know how to code, right, let me just code. But it's actually a good thing to do, but I understand where you're coming from if you want to just jump straight into the code. That's why I did the algorithm first, but I left out some of the functions, because we just go and code those functions and then put them back in the algorithm, right? In the pseudocode. So let's go now. So here's the marks. You have structure, decomposition of functions. Basically, you have to break down everything into functions. You have to show the looping structures, you have to show the appropriate documentation of significant areas and indent the code properly, all of those things, and then you have to show the file manipulation. So all of this here, these stuff, I put as separate parts of the document because remember we're trying to prove to the examiner that we did it. So we're going to actually do the code, and then we're going to show that we put comments for every function, show that you have loops and control structures, show that the code line up with the algorithm, and show that the files are used properly. So here's my sort of layout for coding, which we did with the algorithm already, which says, okay, if you want to code straight from scratch, start off with your structure, then jump to your main, then jump to your welcome function, your password function, your read files function, and then your menu function. Because the main will be able to test each one of these as you go along. And what I'm going to show you how to do is to make sure you test your code as you go along, because you don't want to write out all the code and then realize it's not working after. So you want to test as you go along, and then we'll deal with all the functions. So most likely in this video, I'll get through all of these parts here, get to the menu, and then in the next video, we'll start to knock off all the major functions that we want to do based on the sample IA, right? Sorry to interrupt the video, but this is future me talking to you while you're watching this, and if you are struggling with a certain part of the IA or you just need some way to check over your IA, We do personal one-on-one IA classes. So if you want your IA to get a check over, just to make sure you have all the requirements on the marks, makeITsimpleTT.com/register. Okay, cool. Back to the video. So I'm going to be using a compiler online called Replit, right? If you want to check it out, go to replit.com. You can sign up with your Google account and it'll create an online compiler. And this online IDE basically, integrated development environment. And in this online IDE, you'll be able to literally code just as if you're coding on your computer. Normally we would use code blocks or would use dev C++ as the compiler, and you'll have to install it on our computer and get it to work and whatnot. But if somebody has a Mac, it can work properly, and so the person that has a Mac has to use what is called this thing? I forget the name of the thing Xcode, yeah. Mac will have to use Xcode, and they have all kind of drama and compatibility issues. And since most IAs are grouped now, this is one of the best resources that I could ever use, Replit.com, because you can invite people to join and collaboratively code with you. So if you have multiple people working on the code, everybody could join in and do what they have to do, and then the code will be in one place, and it's easy for a teacher to check. So I use this with all my classes. So if you want, check it out, replit.com, right? That's not paid ad because, well, I ain't get big enough for people to pay me yet. But one day maybe. Anyhow, so I have a sample of it already done, sort of. So sometimes I might just jump across here and copy some of this code and put it back across here. But for the most part, we'll be coding along. But I'm not gonna spend the time to monotonously make you all watch me type out every single thing, right? Because we'll just edit it. I'll show you when I start, and then it will just kind of zoom into the future, and it will show you the finish, right? Because it'll be kind of lame for you to watch me code every single line, especially if you understand certain things, even though you could fast forward through the video. So let's go. We're going to start off by putting in comments about ourselves. So we're going to put in the comment of we're going to be student name, school, project title, project synopsis, date completed, functions, no skills used. Alright, now here's where I'll let you put this in, right? So first name's gonna project title, project synopsis. Project synopsis is basically you're going to say what the code is trying to do, because always keep in mind is a human being that correcting this, and the more you could communicate to the human being to get them to understand what your code is doing and what you plan to do, the better off you will be. So communication is key, and I promise you this will help you out, right? So this is the digitization of a hospital record system, right? That's just a comment there, right? Date completed, whatever date completed, but right. Skills used, you're basically trying to show that you know the skills I had to put in. So you have read from file, read and write a file, search, add, remove, update records, stuff for your functional requirements. You would want to show that I have used these skills, and these are skills that I knew you wanted to look for, and therefore I'm giving it to you because you're trying to convince this examiner you know what you're doing, basically, right? Okay, so once we get through that comment section here, your first job now is to start your code. So you put your hashtag include. All this stuff will be kind of fast forwarded, right? Every time I type in out stuff like that, it'll be like, okay, put include ST. Right, this is to include the things that you need in this particular program. Now, in this particular program, I am not manipulating strings in any way, where I have to like do string copy or anything like that. But if your program is manipulating strings where you have to copy strings or anything like that, or you have to do mathematical functions that different and you have to use math.h or something like that, you could use all your .h files. If you don't know what .h file is, a header file, and your teacher should be able to guide you through. Just know that if you have to manipulate strings, which is copy strings, you have to put include string.h. Right? But I am not manipulating any strings, so I am going to take it out. Because then the examiner will watch and be like, okay, why did you include string.h when you're not using strings in your program? That not making any sense. So you don't want to give the examiner any reason to get vexed at you, right? Alright, so the first thing that we want to do, according to my gauge, is to create a structure based on the input file you created. So back to the input file that we have. This is our input file right here. Alright, we did the input file in the algorithm, so everything is well laid out. We know how it's supposed to work, so we just go and create the structure for this input file that is already created, right? Now, when you're creating a structure, you want to create a structure globally so that any function will be able to use it, right? So a global function means that, a global structure means that it's out of the main, it's out of any function. So whenever it needed to be accessed, you can access it and nobody will get vexed with you. So we're going to put struct database. That's one even. Yeah, struct database. I'm going to just copy and paste the one I have from before, and I'll explain why. Zoom forward now. This is you zooming. Right, good. So I have put in the structure. Right? Here's the structure, and here is the reasoning behind. That's the way how this thing does tab. Let's not make sure the tab is. And then type is tab. Okay, cool. Yeah. Right. Yeah. Right. So what you want to do is at the start, you always want to make sure that you lay out your code very, very neatly from the start. So when you do the struct operation, there are two ways you could indent, right? You could put the curly brackets there, you could put the curly brackets down there. One of the two, right? If you're using the curly brackets to open and close like that, cool, no problem, right? So I have an integer for the ID, a character string for the surname, a character string for the first name, a int for the age, and an int for the status. As the same thing that matches to the file, that'll just prove that this matches. When we have to go to the justification part after, we will be using this to basically prove that we knew what we were doing. We'll take print screens of it, right? Okay, so after you declare the structure, we now have the ability to hold data, but we need to know how much data we want to hold. So in this case here, I have P100, but I really want a maximum amount of patients, so I'm going to put in P max size. Right? Now, we haven't declared max size yet, so what we want to do is we want to pass section for the global variables, because according to the algorithm I have here, that's exactly what I did. I have the structures first, structure declaration, and then I have global variables. So what I want to do is put in global variables will be used in every function, especially oops, right? So I want to create global variables int max size equals 10,000, and what I need to have a int actual size, int actual size equals 0, right? So the actual size will get updated as we go along, but these global variables are to be used in the loops so that we'll deal with the correct size of the file as we go along. All right, so I have created the structure declaration, the global variables, and according to my layout, what's the next thing I said that you should do? After you do the structure in the main code, you want to do the welcome function and then the password function. So let's go. Do I have the welcome function in this one? Where did I put the welcome function? Password function. I have the password function, then the welcome function. Actually, I do have the welcome anywhere. or I put the welcome underneath the read data. Okay, cool. So I'll do it in the order of the algorithm because remember, doing it in the order of the algorithm matters most. It must match this. So after global variables, I'm going to deal with the password function. So let's put in the password. Most likely go down fast forward through here too because you don't want to sit down and watch me type. Password. Alright, good. So far I have put the please enter the correct password. I scanned it into the variable P, and then I want to check to see if, now then I want to return what? If P is equal to code, then return 1 or return 0, right? So we're going to say now, if P double equal code, which is the 1111 I have there, I will return 1, else return 0. Okay, so this password function checks for a passcode. I'll put please enter the passcode, the 4-digit passcode. Please enter the correct 4-digit passcode. Right, good. So actually checks for the passcode and returns one for yes, 1 for correct, and 0 for wrong. Right. So this password function is set up there. So we have, notice everything that is important has a comment in front of it. This is the structure for the file that has the layout of it. Global variables will be used in every function except especially loops. That shows the examiner you understand what you're doing and you understand why you're doing it. Right? Password function, we understand why we're doing the password function. Good, cool. That function is done. Make sure you have a line in between every function or everything. That's white space. You're getting marks for that too, right? After the password, what else did I have in the algorithm? After the password function, we have the read data function. Okay, so now we want to read data. Read data. So if you have a function, just name it like this function reads the data from the input file into the array of structures. Right, so I'm going to read from my input file. Now, when you're using Replit, when you're using an online compiler, you just basically have to create a file in the same branch right here. So you just click new file and name it patience.txt. And has the text file right here. So the text file automatically comes up when you click on it. So all you have to do is go to your text file here, copy all the information, Control A, copy and paste, boom, right? All of your data is inside here. So your text file is already loaded. So now we could just do the function to read the data. So the function to read the data, I think I have it done already, so I'll just copy it and then we'll explain what is taking place. Yeah. That'll make life a whole lot easier. So I'm going to copy it, paste it here. Right. So this function reads the data from the input file into the array of structures. So I'm going to be reading from void read data. It's a void function because it has no job besides just getting the data and putting it into the array of structures. Because the array of structures has been declared globally up here, you see where I have P max size, I declared it globally. So that means we cool there, no problems. It will just have a lot of spaces available, which is 10,000, I believe. Yeah, 10,000. Now, that is set up. I have to create a variable called C because I need to count. If I don't count, I will run into a problem. Because I will, depending on the size of the file, I don't want to use up all 10,000 spaces in the array when I only have 10 things in the file. So I need to keep track of this count because this count here is going to update actual size with it. Right? So, file in. Now, once we declare the file inside here, this is going to be for this file only, for this function only. So we open any file inside here, file in fopen input.txt, and name it patience.txt, open it in read mode, and we go while not end of file in. So while I'm not at the end of the input file, so this is in, while not end of input file, fscanf. So I'm doing the scanfs properly. %d for the ID, %s for the name, %s for the first name, %d for the age, %d for the status. Depending on the ID that you're doing, you might have characters, you might have floats, you might have all sorts of things coming from your input file. But the point is, you must have at least one input file and one output file. So in this example here, I'm doing one input file, one output file. There could be multiple input files and multiple output files if you want to, and that's all fine and good. You could do that if you want. Nobody will get vexed with you. There will be no issue. So every time we read a record from this file, we carry up C by 1, right? So C will go to 1. That means that we keep track of the count. This while loop will go on and on and on and on for the whole duration of the file, which would be, in this case, 12 records. So I should actually get 12 things inside this file. When I'm done, I want to do a printf to prove that it's working. Now, so far I haven't had to do any tests to prove that a function is working, because the only function we did is password function. So we didn't test for the return 0 or the return 1, but we will test that when we get to the main, right? But you see this part here, the read data, I want to put a test in place to show that, alright, I think my file is working properly. In order to do that, here's the easiest way to test, right? This is testing on the fly. Let's have a little printf, line in or wrong anywhere, and you can copy this printf wherever you want. In this one, I put the file is read successfully, and the first ID is this, and the last ID is that. If I could successfully print out the first ID and the last ID, that means I read all the data. You could print back out every single thing just to prove that it was read. Sometimes when things get real bad and you need to debug a lot, you might need to do that. But you don't have to. So I'm going to print the first value, first record, which will be record 0, and then print out the last one, which will be C minus 1. Because C is going up by 1 each time, it's going to count actually 13, because it will do it 13 times. It will be 0, 1, 2, 3, 4, 5, yeah. So I actually want to do the record 0 to 11, but this is going to count up to 12, so that's why I put C minus 1. You probably can't see because it's doing, I'll just put the file as read. Right, the first and last record, right. So I put C minus 1 because we're going to be counting from 0, because all arrays start from 0, right? Just remember that. So this is going to scan from this patient.txt file, and everything should work there. So far I have set up the structure, the array structures, the password, the read data. So now it will be wise for me to jump to set up the main, right? All the other stuff in between, I could fill that out as I go along. So I have the read data, I have the welcome screen. Okay, let me open the welcome screen just for easy. This function displays the welcome message. Right. So I'll put void welcome, because it's a void function, it's not returning anything. We'll just move like that. I'm going to printf. This part you can make it as pretty as you want when you get that time, right? This is the welcome. No, sorry. Welcome to the hospital. We care. Because, of course, the hospital cares, right? I'll put 2 asterisks on it to, sprinkle a little salt on it. Ooh, fancy. Put a backslash in on one side and put a backslash in on the next side. Yeah. Yeah, prettying it up, we could do that after, right? This is a void function, it has one job, to do that. Okay, good. So we have some of the basic functions in place here. Already you've gotten a lot of marks because you have a nice structure inside. You have a password function that is doing some logic, which is like ifs, Remember, your functions should have some robustness to it, where they have like a if here, some loops. You can't just have a function that adding two numbers and sending back the answer for all your functions. You need to have your functions doing things. So I have a function here that is able to do a conditional statement. I have a function here that's able to read from a file. That's good stuff there, because the function has a loop, it has some file reading and whatnot. All that the examiner is looking at to see if your functions are overall the functions are independent units, because you could read your file in the main and you could display the welcome message in the main, but we want to break down the things to independent units so they could do their job whenever they need to, right? So now let's go to the we'll leave out some spaces for all of these other functions that have to go in, which would be all these here: add function, add patient, add print critical patients, update patient's file. Yeah. So we will just put in comments here for those. Right, good. So all of those things we want to put in, and then we'll have also we have our update patient's file. Have that here too. Okay, so we have to remember to come back and do this. I really just want to get to the menu and the main fast. So update patient's file. How long right now? We're on about half an hour. Okay, cool. No, 20 minutes, thereabout. Okay. Alright. So the next thing I suppose I have here is the menu function. But we ain't ready for the menu function yet. All I want to do is start to test out some of these basic functions here, which is the password one and the reading the data one, right? So according to my pseudocode, I have to, in the main, I have to first display the welcome message. So let's go. The main function where all the choices are made. All right. The main function here is where we're making all the choices. Probably when I switch it to Unit 2 IA, I might show you all how to do the choices inside the menu function. But right now, we're not trying to make it too complex. In Unit 2 is when you try to add some complexity to it to make it more efficient for whatever reason. So void main. You could use int main if you want. That's up to you. If you use void main, nobody will be upset either. If you put the int main, of course, you have to put the return 0 because there must be a return value because it's an integer function. Anyhow, I was going to start off by calling the welcome function. Welcome, semicolon. Okay, so let's test the first thing. Let me just do a test for my semicolons that most likely I would have missed because I am a semicolon misser. Alright, seems like we're on this here. Let's see what will happen when we run it. Oh, we have problems. Line 32. Oh, this kind of supposed to be in quotes. Yeah. Yeah, right. Alright, all is line 32. Run. Line 20. What's normally happening here is that when you look at this, this here will show you the line problem. Let me see if I can zoom in on that for you to see. When you have an error, you will see the line and basically how far along it is. So this is saying that the error is on line 20, about space 5, somewhere around there, and it'll give you an explanation. Sometimes the explanation may not always be understandable, but I think this explanation is clear on declared max size. So let me see if I can find that. Line 20, max size. Oh. Right, because all functions work, I have to put the global variables on top. So I have to remember to change that in my algorithm also. So I'll put these here. Right. Because if I use the word max size here, but max size is declared underneath it, it won't see it. So that's why I had to put the global variables at the start, right? So just remember, put the global variables at the start. I'll go and fix that in the pseudocode one time because that's what you should do. Anytime you realize that it's not matching up, then just go and sort yourself out like this. Right, so fix as you go along because this will make sure that your global variable, this will make sure that your pseudocode matches up to your algorithm. Okay, alright, don't need this magnifier anymore. Alright, so they run again and see what happened. Line 23, variable length allotted is not allowed. Sorry to interrupt the video, but this is future me talking to you while you're watching this. And if you are struggling with a certain part of your IA, or you just need some way to check over your IA, we do personal one-on-one IA classes. So if you want your IA to get a check over, just to make sure you have all the requirements on the marks, makeITsimpleTT.com/register. Okay, cool. Back to the video. Alright, so let me do the structure like that and then go and try down here and declare struct patient p max size. Will you accept it? No. Sometimes there are like keywords that they don't allow. Nope. Variable length, array declaration not allowed at file scope. This part of the video might be fast forwarded because I have to Google what the problem is. Oh, I'll be define max size. Hashtag define. Hashtag define. Right. Okay. You gotta define it. Let me see if that'll run now. Define max 100. Define actual size 0. Okay. Behave. Oh, now we have a problem. Line 24, expected colon before. Okay, cool. Right, so I fixed the problem. Okay, problem was that when you're declaring the global variables, I declare them just as global ints. I put like int, max, whatever. But I actually was supposed to use the word define because define will set them as constants. Yeah, throughout the whole program. So, my bad. So as you can see, it says, welcome to the hospital, we care. Can I make this bigger? No. How will I prove to you that it's working? How to make the font big or anything? Alright, I'll add a zoom in. Alright, so you see, welcome to the hospital, we care. So that means that we have run one function and it works. How cool is that? How can I make this bigger? Just let me see if I can change the settings of the console to make it look bigger. Default layout, side by side, replay, font size, keyword, wrapping, ghostwriter, code editor, transmute, select. Nope. I can't make the console get bigger. Nope, that's not what I want. Unfloat, maximize, close. Alright, it'll have to stay like that. Alright, so it says welcome to the hospital, we care. If you can't see that, then I really can't do much for you. I'll just zoom ever so often to show you that the console is actually showing what it's supposed to show. Alright, good. Okay. So we know now for sure that our function for the welcome is working. It does its job. So we get there, welcome. So now we can test the next function. So let's call the password function. In order to implement the password function, I can't remember what had any pseudocode, so let's look at it. Pseudocode password function. The password function should be a while loop. It should create a variable called p, get back the value from the password. Okay, cool. Alright, so I'm going to have to create a variable called p. Declare all the variables at the top because it'll be better. Int p is equal to 0. Right, create a space. You could put a comment saying these are the variables to be used in the main. Alright, so I'm going to say p now is equal to password, and when we get our password, we'll say now if p is equal to 0, printf password incorrect, passcode incorrect. Please enter correct code. Why is console so big? Not supposed to be so big. Yeah, please enter correct code. We say that. No, we're not saying while. Say while now. While p is equal to 0, yeah. Please enter correct code. Yeah, alright, so let's see what happened. So our input is saying now, welcome to the hospital we care, please enter 4-digit passcode. I'll put 11, should tell me, oh, yeah, that's a problem. Stop. Because I have to prompt for the password again. Yeah, I should prompt for the password again. P is equal to password. Yeah. Right, now that I prompt again, it should move smarter now. Let's see, please enter digit passcode 11. No, passcode incorrect, please enter 11. Please enter 111. And then 1111. It should end the program, right? Good. So that's working. All we have to do is make it look pretty now. So let's try to put \n. Put a \n here also. Right. What else I should put \n? Please enter correct 4-digit passcode. I'll put \n here. And next one here. Right. So that should make it look a little prettier. Let's run it again and see. Zoom in on the console. Please enter 4-digit passcode 11. Password incorrect. Please enter correct code 111. Please enter correct code 1111. Alright, cool. Nice. Alright, there are other things that we could do. We could put like a message saying correct code entered. You'll now see the menu or something like that. But yeah, that's alright. So the main has so far the logic of call the welcome message, then call the password function, store the password value inside p, check to see if the password is 0. If it is 0, say it's an error. If the password function returns a 1, however, that means we are correct and we're good to go. I think so. Nice. So according to our pseudocode now, we have everything laid out correctly there. Next thing to do is to check the read data function. So we're going to call this read data function, but the read data function is already written. So if this read data function actually works, then all we have to do is just press let's call this thing, call the read data, and it should print out the values for us. Shouldn't it? Now just get the patient's file open. Right, yeah. Okay, good. Right, so now I have the main here and I have the patients file here in two different tabs. This real nice, Replit real nice with this way, and it make life real easy for you to see the files one time, right? So what I want to do is I want to just go in at the end of this password sequence here. I want to now just call the read data file. Read data, because it's a void function and not returning anything. Suppose I just print out to the screen that the data was read properly. I will know if the data is read properly if the first ID I got is 78 and the last ID I got is 490. So let's see. Please enter the passcode. So I'll put in the correct passcode 1111. Enter. The file was read, the first ID is 78 and the last ID is 490. Is that correct? First ID 78, yep, last ID 490. So that means this read data function makes sense. It works. Now remember, you must read from a file, you must output from a file. So doing this here, you already got like 4 marks or something like that, if I check correctly. Evidence of file manipulation, 2 marks. Yep, so you have the, you get 1 mark for reading from that file and getting all the data inside. Yeah, at least, yeah. So, and is an independent function, so you're just racking up your functions points here. You're racking up your functions points. So we have the stuff working, everything here working up to this point, which is kind of cool. Didn't take that long to display the welcome message. I'll just put some space there, welcome. Ask for the password. Put some logic to show if the password is correct or not. And then read the data. So the next thing that I want to do before we move on to anything else is the menu function. So we haven't coded the menu as yet, so I'm going to go back up and I'm going to, after this welcome function, because according to the algorithm, I have the menu right after this, right? So I'm going to put the menu function. Now the menu function is not a void function. The menu function is going to return something. So I'm going to put int menu. And we're going to list out all the things that should be inside this menu. And I have them all listed here. Copying from your pseudocode into your code is risky, but I think we could take that risk. We're living on the wild side right now, right? I'm going to take this pseudocode here and change it into, this will most likely give me a whole set of errors, but that's all right. All them prints are to change the printf and all that stuff, right? So let me see. All right, so I need to create a choice, int choice, and then read choice. Printf. Here are the menu options. Why not? Wow, this is gonna make my life real hard. Alright, there you go. \n. \n. Alright, good. Whew. Here are the menu options. We'll put a little pizzazz on this too with a little 2 asterisks. 2 asterisks make life a little easier. That's my dog barking there, by the way. And probably the neighbors arguing. Alright, so then we want to do printf here now. I mean, I could have easily typed all of this over, but I do have a bit of laziness in me, like all coders. Yeah. I could bracket it and then thing it. Alright, yeah, I figured out a way to hack the system. Replit kind of cool because it's like autocomplete things for you. So if I fix the printfs one by one. Yeah, more than likely we're going to zoom through all this, like we're going to literally speed through all of this drama because I am wasting a lot of time. Shift that and shift that. Good. Shift that, shift that. Shift that, shift that. Shift that. And yeah, we zoom in through all this because this is totally unnecessary. And semicolons, semicolon, 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 semicolon. Read. Oh, I can't read scanf. Read choice. Then return choice. Whew. Okay, cool. I think I fixed the menu there. I hope I fixed the menu. If I compile it and we get errors, then I'll know why. Alright, no errors. Okay, cool. Alright, so if we have no errors, that means we should be able to call the menu now. So after we read the data, next job is to call the menu. But we have to create a variable to catch the return from the menu. So I'll say opt is equal to 0. So we'll put opt is equal to menu. Alright. And just to prove that it's working, I'll just do a printf. The option shows chosen was %d, which would be comma opt. Yeah. Alright, so we're going to test to see if the menu function is working. Let's run, let's see. So enter the 4-digit code 1111, enter. Oh my goodness, it prints out the menu, but the menu is very ugly. Because yeah, it's very ugly. And I missed out something. Y'all probably saw that I missed out something. What did I miss out? Int choice is equal to 0. Oh, the scanf, the scanf. Yeah. Scanf was supposed to be %d and then and choice. Yeah, that's what happens when you copy and paste code, kids. That's what happens when you copy and paste it. Like, you should just type it over from scratch. But you don't listen to me. And I don't have any backslash n's in any of these, which is really ugly. So I'll have to put backslash n here, backslash n here, backslash n here, backslash n here, backslash n, backslash n again, and then backslash n. Right. So now the menu will like display neatly now. So let's go again. 1 1 1 1 1. Enter. All right. Yes. All right. So the menu comes up. Also, this part here that says the file was read. The first ID is 78 and the last ID is 490. You can take that out after you got it to work, right? So we don't need to see that again. But I'll just leave it in there because somewhere along the line I might mess up things again. So I'll just comment it out. 2/ comment out. If we need to test again, we can test it back, but most likely we won't. Alright, so the menu is coming up there. So if I put in a number, I'll put in 3. It should say nothing. Oh, it stopped. 1 1 1 1 1. Option chosen was 1. Alright, good, perfect. Nice. So I have proven that 1 I could get the menu to work. I could get the menu into a variable called option, and from that option I could print back out that option and prove that the menu chosen was correct. Cool. So you notice how I'm testing as I go along, because I could have easily just be like, okay, the menu works, option, could get everything and then get all the errors, but no. I just got back the value from the function to test to see if the function is working. Once you test that the function is working, now you could go and start to do the if statements for it. Because you don't want to try to do a whole bunch of code and then have errors to debug all the time. Find the errors as you go along and your life will be a lot better. So now we have to create this while loop. This is the last thing I'll be doing in this video here, which is create this scenario here, which is the option choice, and do these. Alright. Is there a way for me to game this system? Not really. Alright, I'll code it like from scratch for y'all, because the copy and pasting didn't work out too well for me just now, so I'm going to just move on. Alright, so this option was chosen option that I could comment that out because I know that that works. That was my test. So I want to say while option is not equal to 0. What do I want to do? No, that's not what I want the brackets to look like. I want the brackets to look like that. Yeah. Right. Replit have this kind of way where this tab using 2 spaces instead of using 4 spaces. So depending on how you put the settings, it might tab 2 spaces, it might tab 4 spaces. For those of you all that like to have your tabs big and wide, okay, cool. But once the indentation is clear and you can clearly see where something starts and where it ends, I don't think you have much of a problem, right? So the 2 space tab is okay with me. The examiners won't have no problem once they are delimited, right? Clearly enough. Alright, so while option is not equal to 1, we have an if statement now. It's gonna get you some marks for the, you see this part where they have evidence of the concept of structured programming, where you show that you have looping structures, you have conditional statements, you have assignments, right? These conditional statements, like an if inside of a while or if inside of a for, that's evidence of you knowing how to code, right? So if opt is equal to 1, for now I just go down and put printf. No, I'll take the same one here. Yeah. The option chosen was opt. You see why I should keep these prints? Just keep them there handy. You can just copy them and paste them back. Right. So that will show you that they chose option 1. And then we go into go very hard and copy and paste these all the way down the road. We're going to fill out all of these things with the logic after. So if option is equal to 2, option is equal to 3, option is equal to 4, option is equal to 5. I believe we have up to option 6 in our code. Option is equal to 6. This is where I check to make sure you record it. Alright, it is still recording. We have up to option 6, and of course once we hit the end of option 6, that means it shows 0. So we will do our printf here. Thank you for using the program. I might have an exit function. We could replace this with an exit function if we want, but we don't have to right now. I just want to test to see if all the options are being chosen, and while I didn't choose 0, if it will still go. 7 or 6 we had in the pseudocode. 6, right? Yeah. Before you end, however, you had a prompt for this option again, or else you'll get infinite loop. So before we end the while loop, prompt again. The reason you're prompting again is because you want to make sure that you will get back on the value each time. and if the while loop finishes, it will reach down to the end here. So each one of these here will choose a function, the option chosen. Based on the option that you choose, a function will be called. So we're going to replace these printfs with function calls as soon as we code each function. This is how you do it modularly, and this is how you save the stress. This is how you save the drama in your life. Just lay this out, test it, make sure it's working, and then we're going to go function by function to do each one of the things that we need to do. Okay? So let's run it and see. Alright, so we know it should say welcome to the program hospital. We care, of course we care. 1111, enter. Right, so let's choose option 1, add a patient. Option 1 was chosen. Okay, option 2 was chosen. 3 was chosen. 4 was chosen. 5 was chosen. 6 was chosen. 0 was chosen. Thank you for using the program. Okay, good. Notice we haven't put in any error situation yet, right? We could modify this while to check for error, to say while option is not equal to 0 and option is not greater than 6. Or we could put some sort of error message. We could put if inside here to say if option is greater than 7, print error, something like that. But we'll do that when we reach to the error, with the testing and the error trapping, right? Right now we just want to get functionality. Once we get the functionality, then I think it's easier for you to get the functionality and then go and look for easy ways to test for the error trapping, because testing for errors has a lot of marks in it where you have to show I don't think they have any tests. Where they have the test boy? Oh yeah, test results. You have to show test results. So normal input giving correct results, and then extreme input giving correct results, and appropriate error message, erroneous. So you have to test for the errors. That means we have to put things in the code to test for the errors. But we will do that when we reach to the testing plan, because I don't want to complicate the code with a whole set of tests for now, a whole set of error messages for now, because a lot of the time students have problems understanding logic or getting the program to work, and this is where most of your marks are going to be made. So let me just get the program to work, and then we could find easy tests to put inside, right? Because you'll waste time trying to test everything and get error messages and all that kind of stuff. So each one of these is going to have a function call, and that works. Of course they're going to be neater, but because these are tests, I'm not going to put our set of backslash ends inside here, because the test will test fairly easily. Thank you for using the program, and good. So far I have a well laid out main that clearly explains stuff. Right. What I can do is I can put in some comments in between here and there. No, I don't need to call the read data. Where do I need to put in a comment? I can put in a comment and say this loop repeats the menu and keeps the program active. Yeah, so that's a nice comment there to show that, okay, you know what this loop is doing, and you know that it's doing that, right? So when we have a while loop that's doing like extensive stuff, especially this one in the main, you might want to do that. Now there is a command in C called switch, which allows you to do almost the same thing here, which will allow you to do switch case. I don't use that because when you go to different languages, they don't have that switch thing. Using the ifs. If you use ifs here, you could use ifs in any other language, but that's just me. You could use the switch if you want. If your teacher requires you to use the switch, go ahead. It'll be switch of case, and then you put all the cases 1, 2, 3, 4, 5, and then you put the error message or whatnot. So we will pause here. So what we've done is we've effectively replicated the pseudocode up to this point, where we have the up to the function working, right? There's a update file patients thing, but we didn't do that yet. So the one function that I didn't do from the pseudocode is the update the patients file, which is basically write back all the data that I have inside. The reason we're going to use our update patients file is every change that we make in the program, every change that we make to the data, when you leave the program, you should update the file before you leave. But we'll do that when we start to deal with functions in the next video. So far, we have a nice layout. This is going to get you a lot of marks just because you laid it out properly. It's neat. Let me show you how much marks you're going to get just because of that. You have structured decomposition of functions. You wouldn't have the 6 marks so far. You probably have 1, 2, maybe 3 marks so far. You have independent units for the functions because you have at least 3 functions that do 3 totally different things. And that's cool. That'll get you about 3 marks. The other marks we'll get from the other more deeper functions. Evidence of structured programming. You have looping structures, you have conditional structures, you have assignment statements, you have inputs, you have outputs. Yeah, you don't get these 3 marks here already just because of what we have so far. Appropriate style and documentation. You have documentation for significant areas. Yes, we documented the top, we indented the code. So this 4 marks here is already yours, just for that. Evidence that the code matches the algorithm. So far, the code is matching the algorithm exactly. So even if your algorithm, even if you stop right now, you still get 4 marks because your code is laid out just like your algorithm, because they can't take away marks from you for not having the stuff. Evidence of file manipulation, we have read from our input file. We just didn't do the output file yet because you need to do the input and the output file. So yeah, 1 mark. So far I have 4, 5 plus 9, 10, 11, 12. About 12 out of the 19. Maybe 14 out of the 19 you have so far just by laying it out properly. All you have to do now is think through how you're going to implement these functions one by one. So next video, we're going to implement the functions one by one, test them one by one, and then the code is finished. So probably in like 2 to 3 hours, you could finish the code if you spent the time doing the algorithm properly. Because you notice I went through the code based on what I had in the algorithm. So I was able to go back to the algorithm and see, okay, what is supposed to be next? What's supposed to be next? If you jump into this code just from coding alone and started to try to structure everything at one point in time, you'll get a lot more errors. But that's okay. There are some people who are okay with that and are able to just run through the code and then reverse engineer it back into the algorithm. But so far, whatever the algorithm had, I have inside the code. What we're going to reverse engineer would be these functions here, because we're going to make sure the functions work, and then once the function works, then we're going to put that back into the code and algorithm, into the pseudocode, and into the pseudocode to make it like neater. Right? So that's the end of this video. Look out for the next one. The next one will deal with code, and then once we finish with the code, we'll just knock off the documentation and we'll do the test plan. We'll have to do a whole video for the test plan, and then we'll just go through the documentation and make sure everything is airtight. And I'll show you how the 60 marks will be laid out, and that will finish us up. So if you watch this video all the way to the end, good for you. You spent an hour of your life learning how to code IA. I hope it helped you. If you want to see all the videos in nice laid out form, you can download the app, learn it, or learn IT. Learn it by makeITsimpleTT. Link is in the description. You go to that site and you download the app, and that app has just all the videos. It's laid out, and I'll have the PDF of this available for you to check through. And when you go through the PDF, you'll be able to see, you could scroll through and stop basically, And all of this code, I'll have all of this code in the PDF also, because you have to paste the code into your document. But I'll show you how to do that when we show you the documentation part also. So, I'll see you in the next video, and thanks for coming. Whatever good stuff people like, share, subscribe. Yeah, oh wow, we're back into that.